All right, to the creators of X, could you please give us some more options for some background music? Because, having only four options ain't fun, and I only like two of those options. So, and even this option that I just played up for y'all is not that appealing. Anyways, welcome everyone. We are waiting on Maurizio to join us to chat a little bit about platform engineering. But while we are waiting, while we're waiting waiting for him, I actually received my book on platform engineering on Kubernetes, and I started to read. Oh, there's Maurizio. Started to read the book, and what was really cool about it is there's some historical context around things we used to do, how we used to engineer platforms, like way back before containers came around, and it's it's both interesting but also funny to see us come full cycle to do the same kinds of things, same kinds of principles that we follow for platform engineering, but bring these into the world of cloud native. So it's like I'm still going through the book. There's a lot of interesting things going on in that book as well, and there are a lot of different areas that I hope Maurizio will share as we get into the space. So welcome Maurizio and welcome Akansha. How are you both doing today?
Hey folks, how are you doing? All good here. Sorry that I missed the initial seconds. I've heard you talking about my book, and thank you very much for that.
Yeah. I just received my copy last night, and I was excited. I broke it open and started to read a couple of pages, and within the first few pages, I noticed, that you brought up a pattern that I've seen time and time again, both in the hardware world as well as in the world of VMware. Because I think you used to work at VMware as well, right, Maurizio?
Yeah. I used to work at VMware before. Always worked on the cloud native space. I never had like a lot of deep insights into the VM stuff, but I've used VMs in the past, of course.
Yeah, and it's very interesting because while I was at VMware, my focus was to effectively engineer and sell and prove the value of a platform that VMware was offering. At that time, they called it the software defined data center, and then eventually they changed the name to the vCloud Foundation. But ultimately, it was still a platform because it provided the necessary pillars for an application to run: your storage, your network, your CPU, your memory, and then some logic and decision making to make all of that data move. And a lot of that has easily translated into the world of cloud native. So, excited to hear more about a couple of things from you, Maurizio. One, your motivations behind your book, and two, what you're seeing right now with platform engineering and how we're supposed to approach this. But before I do pass it to you, I just also want to introduce Akansha. Akansha, you're welcome to always ask questions too. I'm going to shut up eventually, but I've got a co-host here. Oh, let me invite you to co-host as well. I've got a co-host here, so we'll bounce back and forth and ask questions between each other, and Maurizio will be our expert. So welcome everyone. All
Hey Marino, hey Mauricio. So I'm totally looking forward to this space, and yeah, I will jump in and ask questions. And also to the audience, if you have any questions, feel free to drop in the chat below, and we will take it up later on. So yeah, Mauricio, you can go ahead. The stage is yours.
Thank you, Akansha. Yes. Oh, thank you very much. Okay, so there were like a lot of questions from Marino there, and I would say motivations from the book. I think that yeah, trying to share some of the lessons learned over the last 4 years, like of building tools, contributing to different open source projects. I reached to a point where I had enough material just to write a book, right? Like I went to 10 different open source projects in the CNCF space and contributed back with some fixes so these projects can work better together. And at the end of that journey, basically, I said, okay, there are too many things here to share and to share with people just to save time. That was my initial approach. I wanted to write stuff that it took me some time to learn, and then just try to summarize all those learnings and to share with other people so they can just move faster into this kind of like a Kubernetes journey. I'm a very practical person, so it is all about like exercises, trying out different tools, see how they work and how do they relate to each other. right? If you're building a platform, you're trying to basically abstract away some of these tools and combine different tools to achieve something. And the book is all about that. That's kind of like what I try to try to do there. And as Marino mentioned very at the beginning of the conversation, right? I just started the present like the book with comparing with Google Cloud or any other cloud provider that it's being basically building a service that it's composed by a bunch of services that actually they need to work together in some way or another. And I find it fascinating, not only to go full circle with kind of like how platforms were built before and how we're building things now, but also sometimes that because we are not looking into other things that have been built before, we are just trying to redefine everything. And I actually think that we can save a lot of time by taking good things from the past and then just trying to see how the new things that are coming, fit into some of those paradigms and ways of doing things. So yeah, that's I think that using an example of something that people might know, like a cloud provider, if you're already into using cloud providers, it becomes easier than to explain the journey and why certain tools in the Kubernetes space, appeared and became popular. I don't know, Marino. Hopefully that reflects kind of like also on your journey, more on the hardware side, on the VM side.
Yeah, I mean, it definitely does, right? And I'll go back in time and talk about some of my data center days. One of my key activities when I was out in the consulting space was to design and implement data centers for a variety of clients, and that data center setup was not just, hey, let me just throw a server here and then throw in an OS and we're off to the races. It was a lot more than that. It's a strategy around how you would design a data center for heating, cooling, electricity, capacity, et cetera, and then also all the necessary networks into that data center. And then you also have to consider, what kind of systems you need to run these various kinds of apps. Some apps require high-speed IOPS from your disk, right? We're talking about solid-state disk because we have so many read writes going on very quickly. Simultaneously, we can't attach disks directly to hardware. We have to have them isolated because we want to use a pool of disks, right? We want to aggregate our disks and carve out what we need. This is the whole world of storage and storage area networking. But you combine that with, okay, now I need to protect my data. Now I need to move my data. Now I need to secure access points. All of what I'm describing. Oh, I also need to automate this. And then, oh, by the way, offer up an opportunity or some mechanism for my developers to log into some of these systems and deploy their apps. We were doing platform engineering 10 years ago, 15 years ago. Now, the difference between what we did back then and what we do today is that a lot of the things we do and process today is in software. So it makes it extremely easy to consume. I think the bigger challenge, and I think Maurizio, you hit this in your book, is around interoperability. You've got all of these different tools and pieces that exist in cloud native to be architected together to effectively, run different kinds of applications. What's your thoughts on how we solve the interoperability problem? Like what are ways we are solving that through platform engineering?
So that's a very interesting question because remember that before when we used to do like, imagine Google Cloud or Azure or, or Amazon, right? These are like internal teams inside these companies building different services, but they can communicate between each other and they can collaborate pretty intensely because they are like part of the same company. Most of the CNCF projects are created by different companies with different motivations, with different backgrounds. Some more on the operation side, some more kind of like on the application, closer to applications and application tools. So it's very interesting, and this is something that I really enjoy, right? Like we're having this conversation with people coming more from like the networking space, mostly like from the storage space, and I'm coming more from like the application space, from the application delivery side, from closer to developers, understanding developer tools and all these kind of things that are completely different, and they have kind of like different intention and different purposes when they are designed. So I'm always amazed on collaborations across projects in the CNCF space and how companies come together to actually solve common use cases that initially maybe the tools were not designed to cover. And I keep finding these, right? Like there are like rough edges in all the CNCF projects that we can just all go there and collaborate. And that's why it's so important to keep sharing with people, how easy it is to get involved with these projects and help them to actually work together, because it might work together for someone else, but they are not working for you. And that basically means that there is something there that is missing. And contributing back with these pieces is extremely important. Internally in your company, you can, of course, will need to write some glue in order to make these projects to work together. But we are going towards a place where the idea is that all that glue, it's being shared and contributed back to projects where it makes sense. And sometimes just understanding that other people is already using this combination of projects. And I think that that's where we are today, right? Like today, we have at least when you look into the CNCF landscape and the growth of the projects, you see that they're like top 10 projects that are already well known. People is actually adopting them, and that basically means that we need to look into this combination of projects and what people is trying to do with them in order to make sure that we cover a wide range of use cases that actually will be documented and people can start using right away instead of figuring out how to put all these things together. And again, that's one of the main focus of the book, just trying to show multiple projects working together, the gaps between the projects, and the some of the pieces that companies will need to build their own today based on the status of the projects. And I know that more tools are coming just to solve some of these things, but I wanted to show you practically what kind of things you will be facing today.
That's awesome. Okay, before I pass it to Akansha for more questions, I have one. Eli 5 platform engineering. Explain like I'm 5 platform engineering as simple as you possibly can. Let's make a simple definition for everyone here.
Cool. Okay, so there are different angles, but let's take one, the most easiest one. I would say that it's building abstractions to enable different teams inside organizations to perform different tasks without understanding the tools that you're using, to provide these functionalities. I like that because it's very close to my heart, and it's focused on the problems that you're trying to solve and not the tools that you're using to solve the problems.
I love that definition. Oh my gosh, that's going to be a tweet soon. All right, Akansha, it's all yours.
Yeah. So, Mauricio, I had one question. So, like, how do you approach the strategic design and ongoing maintenance of a platform for development, testing, and deployment tools within a DevOps environment, considering the need for customization to meet specific business and software development needs? So, what factors guide the decision making process in selecting the components and services for the platform?
That's a very good question. So there are like two things. There are two aspects that I usually consider in order to answer like a very complex question like that. Like which tool is the best for me? First of all, you need to kind of like learn. Like teams needs to start learning on how to evaluate tools, right? Not because this tool is becoming popular, is the best tool for solving the problem that you are having today. So understanding how to evaluate tools and the community behind these tools when we are talking about open source projects is really, really important. So first of all, understanding what's out there, right? Like if you have 3, 4 different options, understanding what these different options are about and what are the key differences is really important. And then what I cover there in the book, it's about abstracting them, right? Like in some way, making sure that if you decide to go for one tool, you don't get tied to that tool in the long run. So you can actually swap that tool for another tool, and again expose more like platform capabilities for the users or the consumers. In the case of CI pipelines, for example, it's all about like what are the hook points for teams to define their pipelines. I'm not talking about abstracting GitHub actions or stuff like that, but there are like different projects that will allow you to say, I can create a library of tasks and pipelines that can be shared across teams. And that's something that I will definitely look into the tools that give me to the platform engineering team the possibility of creating libraries or shared collections like of things that are pre-made for teams to use. That's something that I will definitely recommend you when looking into different tools. I In the book, I think that for CI, I analyzed like a couple of tools like Tekton. I think that I cover a bit of Argo workflows as well. There is also some mentions to Dagger, which is a project that I'm loving more and more lately because it actually takes this concept of abstracting pipelines and allowing people to run pipelines locally as well as remotely in GitHub Actions or even in Kubernetes to the extreme. And I like the approach there. So yeah, again, tons of tools. It's up to you what you choose. But at the end of the day, you need to think about it of capabilities instead of I'm exposing this specific tool for my teams to use. Because the moment that you do that, then you are tied for the long run with that specific tool. I hope that makes sense.
Yeah, thanks for sharing that. So let's talk a little bit about delivering applications while using platform engineering. So just to set a bit of content for app delivery for folks that may not be knowing. So imagine you have built a really amazing application that works perfectly, including the edge cases and all. But what good is this app if your end users cannot use it? That's where we have a system in place to deliver these applications to our end users. Traditionally, this could be a new application version or a GitHub release. However, in this model, your end users still need to manually download the newer versions. There are also methodologies such as GitOps that enable developers and operations teams to deliver the application. So my question is, so how does platform engineering comes into the picture that delivers that like basically simplifies the delivery process and creates the necessary abstractions?
That's a really good question as well. I would say that on the delivery space, I'm really big on GitOps in the sense of codifying how do you configure environments to deploy and run applications. And there are like tons of tools in the CNCF space just to do that, which I think it's a good sign that people is like the industry is going into that direction. So I would separate a couple of concerns there. One is how do you provision infrastructure so you can run your applications, no matter if that's for development purposes or for QA, for example, or for production environments. And the other space is how do you get your newer versions or like the new versions of your applications deployed in front of your customers. I think that automation is key for all these, for all these scenarios. And then again, just choosing the right tools to make sure that teams don't need to worry about connecting to clusters to deploy applications and making sure that teams have the right tools to, for example, implement different release strategies is fundamental, right? Again, from the platform engineering point of view, it's all about enabling teams to do the things that they are supposed to do. And if you think about like a delivery team that is in charge of getting new versions out, making sure that these teams can experiment by doing canary releases or by doing A/B testing just to verify which version of the application works best for the customers is really important. And in the book, I mentioned a bunch of tools for like knative serving, and I mentioned a little bit of traffic splitting, and I mentioned also Argo rollouts to just highlight that there are different tools to perform similar things, and you will need to actually at some point make a choice of which capabilities do you need, what kind of things do you want to expose for these teams to use, and based on that, you can like decide on this tool is the best tool that will solve the problem that I am having today.
So
Yeah.
that's fantastic, Maurizio. I'm actually going to put you on the spot now and ask you for your opinion on what a stack actually could look like. I know you talked a little bit about some of the technologies, Tecton, Argo, a little bit of Dagger, but if you were to build out a true platform, right, in your eyes, in Maurizio's eyes, what would that platform look like? What would be the tools that would be used? Because I want people to also visualize this in their head, right? We've talked
Yeah.
about some ideas, but what does that stack look like?
I will probably defer the question in a way that, yeah, so basically it's a very difficult thing because well, just to answer that question, I will say this, right? Like when I started writing the book like 2 years ago, I started with a set of projects. I think that there were like 12 different open source projects that I wanted to cover, and by the time that I was going to print the book, 3 of those projects were dead and non-existent anymore, right? So whatever I say today, I know that in 6 months it will be completely different. And for that reason, I would like to lead people to this initiative that it's not the CNCF initiative, but it's called Kanui.io, which is basically an initiative that I think that it was created inside of AWS with a bunch of customers. basically looking into which open source projects they are using. Imagine like AWS customers being pretty large. They went out looking to these customers, what they are using, and then they created some reference implementations of their internal platforms. And it's super funny to look into the selection of tools that they are mentioning there, because are pretty much the tools that I'm mentioning in the book, but also including other tools that are not in the CNCF, like for example, Terraform, right? Like people is using Terraform to provision infrastructure. So it's no surprise to go there like into like this project and see that customers are using Terraform. So Terraform is there. I know that Crossplane is also there, which sounds a little bit, contradicting at first, but it makes a lot of sense. They mention also Argo all over the place. They mention Tecton as well, and I can check the website. But yeah, so I would say, you need something for CI/CD. You need something for GitOps. You need something for provisioning infrastructure and managing multi cloud resources, and that's maybe Terraform. That's maybe Pulumi as well. And then you need, for example, you will need some kind of like identity management solution for it. They are mentioning a project that's called Keycloak there. That's something that I used to contribute back in the day, like more than 12 years ago. I remember that project being around for identity management. It's a pretty complicated project, but it does what it does, and it kind of works. And yeah, and then security like Cert Manager, you will need that for sure. And tools that, at least in my opinion, it makes a lot of sense. I'm really looking forward to see what's the next wave of tools coming, right? Because we reached to a point where we can create clusters, we can configure clusters, we can secure clusters, we can observe and monitor, like with open telemetry and all these standards. Already we can actually understand what's going on inside the clusters. So what's next? And I think that what's coming next, it's all about application and application development and going up the stack, right? Like with higher level abstractions to make the life of people using all these tools much simpler.
So let me ask you another question. Should you build it or should you buy it?
Oh, that's a very difficult one. Let me see if I can find the website.
You're going to
Yeah.
find the answer in your book?
I'm just going to ask ChatGPT or something. No. So that's a very good question, and I think that I do go into this a bit into the book, but the idea here is that I'm describing projects that run on top of Kubernetes, right? So it's really apt for teams to understand if Kubernetes is the answer for them. If Kubernetes is the answer for them, then definitely you will need to build the expertise to have a platform team to glue all these tools together. And I do see a lot of value in doing so, right? But it really depends the scale of the company that you're working for and their maturity level on these tools. Talking about platform engineering, I think that it does make sense if you are if you are already kind of like inside a company that is heavily invested in Kubernetes. Trying to talk about all these tools and the complexity that these tools brings into the picture, if your company is still not sure about Kubernetes, that's where I think that maybe looking, into cloud providers might be easier. But if you're coming from this heavy background on Kubernetes and open source, 100% I will build it myself. I've seen people building it. I have a lot of friends building this kind of stuff. So I know that I can like have the right network to go and ask questions if I don't know, if I get stuck with something. And that's pretty much going to reach out to CNCF and going to KubeCons and meet people who is doing amazing work on this space.
Yeah, there are a lot of thoughts around building versus buying, and sometimes it also comes down to the needs and speeds of the business, right? Like the business has to move at a certain speed, and spending cycles on having to build out a platform and then making that available, tunable, customizable for developers may impede the release of some really cool features or products, and actually can inhibit a competitive advantage, right?
Yeah, I think that also, like, if you think about like adopting a cloud provider, right? Any of the big ones, right? Like Google, Amazon, Microsoft. So, like, no matter what you are doing, you are going to basically first of all learn about their services and what these services can do for you, and then probably building this abstraction on top of how do you use these services, right? I think that there is no way to escape building the kind of platforms that I'm defining inside the book. for like each organization, no matter if they're going straight to a cloud provider service or if they are using tools inside Kubernetes clusters. I think that all the things that I'm discussing there are like, lessons learned in general that can be applied to any of these worlds. Because a cloud provider will not give you what your company needs exactly. You need to build like some practices on top of those services and the way that your teams are going to use those services and encapsulate that into some kind of like glue code to build the amazing features, the amazing features that you're trying to deliver to your customers. So I think that it's all about practices, and it's all about how do you put things together, which is something that I really like. I come from this system integration background that it feels that that's my space. How do you understand all these different things? How do you put them together? And then how do you start creating some kind of like libraries or shared learning patterns that you can share across teams so they can do the stuff that they're supposed to do?
So that's, it's a fascinating perspective because, as you look at cloud platforms, each one does does it pretty much the same, but offers different ways to achieve the same goal, right? Now, in the situation where you have a multi-cloud strategy, and maybe for some folks they may not agree with the multi-cloud strategy, but some folks might need to use it because they're trying to leverage some of the best of breed of services that exist across these different clouds. Now, in working with VMware or working for VMware at the time, one of the biggest things they were after was the multi-cloud story. Hey, you could do multi-cloud, run in Azure, run in AWS, GCP, whatever. But the one key aspect of that is it had to be with VMware on top, right? So you needed to run the software-defined data center or the vCloud, whatever the hell they call it these days, in that cloud provider. So all you're really doing at this point is just running vSphere with NSX and a bunch of other fancy wrappers in a cloud provider's bare metal environment. And that's actually no different than doing this in your data center. Now, the reality though is this was heavily attractive because a lot of organizations, one, had already invested heavily into the virtual machine landscape, and they continued to do so because it was the best place for them to run applications. It offered them some flexibility, didn't really have to hook into anything specific, but still really needed some sort of hypervisor and control plane to be able to drive a lot of these operations. Now, how does that compare to what we're seeing in multi-cloud activities in the cloud native space? And I'm bringing this up because when you think about how VMware was doing it, all they were really doing was giving you the experience of vSphere in the cloud so that you didn't really have to change much up. You could just do, the fancy vMotions, and, your VMs would replicate themselves pretty easily. And it almost feels like you've got this one massive super cloud. In cloud native, that's different. That's an anti-pattern. Actually, we don't want to be doing that. We actually want to be allowing ourselves to leverage the best of Kubernetes, but not necessarily hook ourselves into, a specific cloud provider. So let me ask you, like, how does platform engineering apply to multi-cloud? And how is that different from what VMware was doing? And maybe others like Red Hat and how they were doing OpenShift and OpenStack.
That's a very good question. I don't know if I have all the answers for that, but in general, I tend to see like the Kubernetes APIs and at that kind of like the abstraction layer across multi-cloud, right? So whatever we build on top of these APIs, we know that we can just run across different cloud providers, and we will be able to actually reuse all the tooling that we know already. And I think that that's the major benefit here, and that's why companies like as you mentioned, like Red Hat, it's building OpenShift, and VMware built Tanzu, which is basically tools on top of the Kubernetes APIs, so you can go to multiple cloud providers and manage infrastructure, manage stuff, like looking into the Kubernetes APIs. I really like that space, but in general terms, I tend to believe that if you learn the Kubernetes abstractions, then you don't want to learn higher level abstractions that do not apply to your organization, right? Like what an application is, it's very close. It's a definition that it's very close to the organization itself. So generalizing what an application is pretty hard, and that's why I tend to think that from the administration point of view, like things like OpenShift and Tanzu can give you a lot of advantage. You can actually have like a unified experience across cloud providers, and how do you deploy and release your applications into their Kubernetes offerings. But at the same time, I think that you will need to spend a lot of time learning about how they build these abstractions for you. And if you want to extend them, then you need to figure it out how extensible their abstractions are. And I think that that's the main reason why most organizations are building their own abstractions and then just going and defining their own journeys to the cloud. I would tend to think that most of these tools are about like operation side of things more than application delivery things that are much more difficult to abstract away. I'm not saying that they do not have some good stuff in there, but I'm saying that most companies will want to customize those things to the extreme to make sure that it fits to whatever they are doing.
I completely agree. I mean, I think that every company is going to have specific requirements that are going to drive the way they build out something like multi-cloud, or maybe decide maybe we won't do multi-cloud and we'll do uni-cloud, but spread it across multiple availability zones or something to that effect. All right, let's move to a specific topic. I actually want to know a little bit about Dapper and how that ties into platform engineering, and then tell us a little bit about what Diagrid is doing in that space.
Yeah, definitely, 100%. So basically, I'm working for this company that is called Diagrid, and we help people to run cloud native applications at scale. And we do so by being heavily involved with a project that is called Dapper. It's a project that was donated to the CNCF in 2019, I think. It's pretty mature, and what it does, it's basically it offers you kind of like out of the box some APIs for developers to use. And these APIs are trying to simplify how do you build and create cloud native applications. So it's a set of APIs plus a set of best practices and cloud native design patterns that will allow you to focus on building your applications and writing your application's code and features instead of thinking about how to contact the database or how to send a message via Kafka and all that kind of stuff. And the company is basically behind the open source project alongside with Microsoft and a bunch of other companies in the in the CNCF pushing for the project to grow and grow. And we are just building a couple of products around that. Like we just announced at KubeCon, like our managed service, kind of like the Dapper as a service kind of thing, that gives you kind of like this, multi-cloud APIs to connect to infrastructure across different cloud providers. But also it allows people just to write their applications against this API without thinking about where those APIs are hosted, who is running them, who is managing them. We will just take care of all that space for you, and you will just build your applications and run them wherever you want. We are not about like running your applications. You run your applications. We provide like the APIs to connect to multi-cloud infrastructure and also to scale up and implement best patterns when building distributed applications. But yeah, Dapper is a very interesting project, and it fits the platform engineering story because I think that this is where we are going. I think that we are going closer to applications, right? When I see the Kubernetes space, I totally see that we are nailing it down how to run workloads at scale. We know that if we create containers, we deploy them into Kubernetes, we scale them up, we can do a lot of really, really amazing stuff in there. But we haven't spent, well, I would say that there is a few people spending time about like thinking about how do we connect all these containers that are running at scale together and how these containers can access infrastructure without like actually with like a level of indirection that allows developers not to think about where that infrastructure is or who is provisioning it or how to connect to it or how to get the passwords to connect and all that stuff. And Dapper kind of like sits right there in the middle. You run your workloads on Kubernetes or even outside Kubernetes, and then you use Dapper to enable these containers to talk to each other, not only kind of like at the networking like space, like just find where the service is, but also like retry mechanisms, also observability space in there, and also how do you connect to available infrastructure like databases, message brokers, secret stores, and all these things that developers will need to build their applications. It's applications are all about that, right? Like reading data, storing data, emitting messages, consuming messages, and reacting based on what's going on in the around them, right? So we are trying to facilitate that journey for developers.
So you did mention something that Dapper does. It
Mhm.
actually provides the ability to do some retries and helps the app make those connections to other apps or other services. Now,
Yeah.
obviously, I work for a company that does service mesh, and
Yeah. Yeah.
I work in the Istio space, and
Hmm.
Istio does exactly what you described. So, how do
Yeah.
you differentiate between what Istio as a service mesh does and what Dapper does? And let me also layer in the fact that
Hmm.
I know Dapper uses this concept of sidecars as well. So,
Yes.
how does this allow these two technologies to work together without overlapping or conflicting in any way?
So that's a thing. That's a good thing, right? Like they overlap in some of the features, but that doesn't mean that they conflict between each other, right? Like you can actually use them both together, and that shouldn't be any problem whatsoever. What Dapper focuses on, it's mostly like on the APIs on top of those features and how those features are exposed to different teams. So, and I totally, this is something that I would love to work with you, Marino, and some other like folks in the Istio space, just to make sure that the integrations between these two projects actually shows that they are not conflicting in any way and that they can be used together, right? Because I tend to see a lot of people that have looked into Dapper and they get confused about, oh, this looks like a service mesh, but actually it kind of is, but at the same time, like the main advantages and the main things that Dapper brings into the table are the APIs that are exposed to applications, not so much the networking connectivity across the services, right? And the mechanisms for retrying and all those things. I think that having different tools implementing the same patterns, it gives some kind of validation that people kind of need those kind of things like MTLS, retry mechanisms, resiliency policies, and all this kind of stuff. And that developers, even if they care about these things, they shouldn't be spending much time on those, right? Like mostly like the platform should provide these capabilities to them, and they should design applications knowing that those things are going to be provided. I would say that I'm guessing that you would agree with that.
I absolutely do. I think that there's a key differentiator there between how Dapper views apps versus how Istio views it, right? Istio is
Mhm.
more a little bit lower in that stack, right? It's more
Yeah.
aligned to that infrastructure layer or level, even though it is dedicated to making sure that apps don't need to bake in libraries or functions to be able to call each other.
Mhm.
So what would be really cool, and this
Yeah.
is a sidebar conversation where we maybe do a live stream and dig into Dapper at some point, and I'll
Mhm.
hit you up about that very soon. So we'll figure that out so I can learn a little bit more about Dapper and understand how it works and really know that it's not a competing technology and
Yeah.
demonstrate that to the other folks out there. Um,
So
Go
before you
ahead.
close that, before you close that idea, right? Like what I think that we should do, it's because as you mentioned, right? Like Dapper and Istio uses sidecar, kind of like sidecars to implement kind of like the service mesh. Totally like a proof of concept there would be to have like Envoy running in the same process as as the Dapper sidecar, one dealing with the networking infrastructure layer to connect things, and the other one dealing with exposing APIs to applications. And I know several organizations interested in this already, so we should definitely get this working. And if anyone listening here kind of like this conversation is interested in helping to push for like a small proof of concept around that, please feel free to get in touch and drop us a message.
Like, I can ask a question.
Yes, go for it.
Yeah, so we are essentially creating the entire software supply chain using our platforms or IDPs. So, how do we make sure that the entire supply chain is secure? Would it be a good idea to rely on just the platform's built-in security mechanism, or would it be a good idea to introduce something like Trivy or ArmoSec within the platform? Also, what are some considerations that one must keep in mind when creating an IDP for managing efficient app delivery?
All right. Yeah, that's okay. So twofold question, right? Like one was about security, right? And
Yeah.
that's a very sensitive topic, right? So for that, you need to choose the right tools for doing the job depending on the regulations of your company and your organization. Different companies will have different regulations about how to deal with security and the security standards. So I don't think that I can recommend a single tool for doing that. But yes, some vulnerability scans, making sure that you implement SBOMs and making sure that you can have traceability about like who is building the software that you're running and the dependencies of that software and understanding, if any vulnerability pops up into your system, how much time does it take you for to fix it or to just get a patch? Understanding all these considerations are really important, and I think that it's one of the main things that a platform engineering team will be in charge of doing. And yeah, sometimes you can just buy services to do some of that, but understanding the entire space will take you quite a while. I'm not a security expert by no means, so I don't think that I can comment much more than that. And I know that there was a second question, but I don't remember what was the second question. Sorry.
Oh, yeah. The second question was that what are some of the some considerations that one must keep in mind when creating an IDP for managing efficient app delivery?
Okay, yeah. So just to okay, so for like efficiency wise, I think that I closed the book with that topic on how do you know or how do you make sure that whatever you are doing in your platform is being efficient and also it's actually helping your teams to be more productive. Because I think that if you're building a platform that it's making people to go slower, you should know from day one, right? So measuring, I think it makes a lot of sense. I haven't seen much around this, but in general, the idea of understanding if you are kind of like adding a new tool, let's say you add Dapper or you add Istio or you add Argo CD, and then that's causing your teams to deliver less features in the same time frame as you were doing before, then you need to consider and or try to understand why is that, and maybe if one of the tools that you are adding shouldn't be exposed to these teams, and maybe you can just use it behind the covers instead of pushing teams to learn about these new tools. I think that it's all about that, measuring and understanding the impact of changes on the platform that you are defining and that you are creating, and making sure that teams doesn't need to change their entire workflows every time that you add a new tool into the system. I think that measuring and making sure that teams do not need to change the way that they are doing their work are two fundamental considerations to improve agility and just improve the ways of delivering software.
Thanks for sharing that perspective. So, like, as with any new or even old piece of tech, some misconceptions are floating around what they are or how they work. So, what are some common misconceptions about the relationship between app delivery and platform engineering?
Ooh, we are entering into the realm of definitions. I'm pretty bad at that, but I would say that platform engineering it's something at least in the context of the book that I wrote, which is the Kubernetes context, is something that if you're adopting Kubernetes, you will need to implement some of the platform engineering practices that I'm describing there, in the sense of understanding which tools are available for you to use and understanding how these tools will work together, right? So in that context, platform engineering, at least to me, it's a more practical thing that you will need to do if you're adopting Kubernetes. You will need to understand the available tools and how do how do will play together for solving some particular use cases. That probably, so it has a lot to do with application delivery and again releasing new versions of your applications in front of your customers. But actually, how much of this you expose to the teams that are in charge of deploying and releasing the new versions is completely up to the platform team to define, right? Like, what interfaces are they going to expose to enable other teams to deliver more software? It's completely up to them. And sometimes exposing Kubernetes is not the answer, mostly because it will take the consumer teams a lot of time to learn and to standardize around kind of like the knowledge that they need in order to deploy stuff in there. Uh, that's why when you build platforms, then you will need to kind of choose your predefined kind of like set of experiences. I think that where we are going now, you will see that people will start showing more tailored tailored experiences on top of Kubernetes built by platform teams. And there are some very generic examples like container as a service platforms that basically allows you to say, give me your container, I will run it for you, and it will be scaled by the platform, it will be secured by the platform. You don't really need to worry about that kind of stuff. Or higher level abstractions like functions as a service abstractions that will basically take the function. So like a developer will create just a simple function like a Lambda function and the platform will containerize it for them, will run it for them, will scale it up for them, and it will connect the function to the entire available infrastructure for them without them doing much besides coding the function, right? Like coding the function and understanding what a function is supposed to do and how is it supposed to connect to other things. But I do see more and more of that coming kind of like into our space. And I believe that we will start seeing more complex experiences being built around the concepts that we already know, but making the life of consumers much easier.
Awesome. That was a really good and great explanation there, Maurizio. I've got one more for you, and then we'll wrap up. And that question is, there was a company out there last year that was touting this idea that DevOps is dead. I actually want to know your thoughts about that and how that ties to platform engineering, and if that company's got it right or got it wrong.
That's a very good question, and that basically means that you know me very well. So I know the company that you're referring to. I try to stay away from that as much as I can, mostly because we know kind of like we know the tech industry how it is, right? Like we will create terms, and then we will try to justify that these terms are the right things for companies to do. And I've been always pushing back on that in the sense of showing practically how things can be done instead of trying to come up with definitions or new terms that people will need to follow. Unfortunately, the title of the book is Platform Engineering on Kubernetes, which is pretty much along the hype of the term. But it's interesting. If you look into my blog, you will see that there is a blog post explaining why I decided to change the title. Because originally, when I started writing the book, platform engineering was a thing, but not in the context of Kubernetes, in the way that we are seeing it now at KubeCons and at the CNCF space. So originally, I titled it Continuous Delivery for Kubernetes, which has different connotations. When people saw that title, they thought about CI/CD only. But the reason why I chose that original title was because I was focused on the delivery practice, right? Like, how do we go from like writing application code to having that application running in production when production basically means some Kubernetes clusters? What tools do we need? And the same approach and the same set of tools I'm using to describe how people, it's basically going to create these platforms that basically are abstracting away these tools and exposing capabilities for teams to deliver software. So all the DevOps versus platform engineering conversation, I don't think that I'm that interested in that conversation itself. And I do see teams like, for example, like the Tag App Delivery at CNCF and the Platform Working Group as doing kind of like an amazing job of coming up with definitions, looking at the industry and seeing kind of like what people is talking about and distilling that into a way that everybody can understand without being driven by marketing or by other strange motivations there.
I 100% agree with that. It's a mindset and more of a process and approach, and we don't want to get caught up in a lot of that marketing hype. I mean, the ideologies of DevOps still align to what we do in platform engineering. Now, that being said, we want to make sure that we're cognizant of your time, Maurizio. So we'll end this space very quickly and shortly. I'd love to just get some final thoughts from you around what's going on into 2024, and we'll close up.
Sounds good. All right, so 2024, a little bit of predictions there. At least from what I'm looking for, this year we saw a lot of like AI, right? Like we saw a lot of AI at KubeCon. We saw a lot of machine learning. How do you run like machine learning workloads on top of Kubernetes and all the stuff that is coming on that space? I see the industry maturing, right? Like Kubernetes, it's a very generic tool in a sense that it's abstracting multiple cloud providers. So I'm expecting now to see more and more complex use cases like running machine learning workloads on top of Kubernetes become easier and also cross cloud. On the platform space, what I'm expecting to see is that uh, like a little bit of a change. Instead of looking into how different tools fit into the platform story, like let's say how Argo CD fits into platform engineering or how Crossplane fits into platform engineering, more about like cross collaboration between projects and how they together fits a larger story. And that takes me to the next thing that I don't know if that's coming next year or later on, but how do we build custom experiences for teams to consume these platforms? And which tools starts popping up in that space is something I'm really, really interested, right? Like generic, well, not generic, but like generic control planes for managing multiple clusters and multiple tool across different different cloud providers might be kind of one interesting thing to see. I had some conversations around that space, and I do believe that there are some people working on that. And yeah, stuff that people is doing all the time. Like no matter for which company you work for, if you're building a SaaS offering, like a software as a service offering, and you're targeting again, you want to run on top of Kubernetes, we need to make that journey easier. There are so many startups building exactly the same thing, like the same control planes, the same mechanisms, just to provide the software as a service on top of Kubernetes, that I hope to see more of that next year, to be honest. And yeah, tools, and more tools to simplify the platform building experience. They are coming, I know for sure.
I love that. Thank you so much for that outlook, Maurizio. I think it's important for folks to really start thinking about that into 2024 as they're building their platforms for apps or deciding which ones to buy. All right. Well, again, I want to thank you so much, Maurizio, for coming on board and sharing a lot of perspectives and knowledge around platform engineering and really sharing bits and pieces from your book. I encourage everyone here, if they're very interested, go check out the book that's shared up there and the Jumbotron. Pick up a copy, support our author here. Fantastic content. Next week, we will have Michael from GitLab coming in to talk a little bit about CI/CD and GitOps and all the cool stuff around application deployment. And Akansha is going to lead that. And the week after, we're going to have Neela that's going to come up and talk about observability and how to instrument that with our applications. So looking forward to it. Thank you all for coming. Have a fantastic rest of your day, rest of your week. We will see you next week. Take care, everyone.
Thank you, folks.